Hi everyone, in this video lecture I'm going to be discussing quadratic sequences. So recall that in the previous video lecture we had discussed arithmetic sequences, and an arithmetic sequence was a sequence that had a first common difference. So let's keep that in mind. For now, let's consider the following sequence. So we're going to consider a sequence which has terms 6, 12, 22, 36, 54. Right, so previously at our disposal with arithmetic sequences, we would compute the first difference. So let's proceed with the similar strategy. So let's compute the first difference here. So the difference between 12 and 6 is 6. 22 minus 12 is 10. 36 minus 22 is 14. 54 minus 36 is 18. So let's stop and let's now observe what has happened. We have computed the first difference for this sequence. But notice that in the first difference, this difference is not common. Each of the terms are different from one another. So that means that this is certainly not an arithmetic sequence, and we cannot use any of the tools or formulas that we had developed before. So since we no longer know how to proceed with this sequence, let's just repeat the procedure. So let's compute the first difference again. So we're now going to compute the first difference of this first difference, meaning we are now computing the second difference of that original sequence. So what is 10 minus 6? That gives you a value of 4. 14 minus 10, a value of 4. 18 minus 14 again gives you a value of 4. So in here, we now observe that the second difference is now common. So this now seems to look familiar to what we had encountered before. Right, so any sequence that has a common second difference, like what we had encountered above, is called a quadratic sequence. Right, so just like we had done before when it came to analyzing patterns and looking at sequences, one of the main questions is, how do I determine the general term? So what is the nth term? The nth term, Tn, of this quadratic sequence or any quadratic sequence. So the general formula for the nth term for a quadratic sequence is an squared plus bn plus c, where a, b, and c are constants. But now the question is, how do we solve for a, b, and c? Right, so it turns out that if you have that your general term is equal to an squared plus bn plus c, then the second difference that we had encountered, the common second difference, is actually equal to 2 times a. So 2a is the second difference. Right? So in here, that means that this value 4 is equal to 2a. Right? In addition, 3a plus b is actually equal to the first difference between the first pair of terms. So t2 minus t1. The second term minus the first term, which gives us this value of 6, is equal to 3a plus b. And finally, a plus b plus c is equal to the first term in the original sequence. So here's our first term in the original sequence. That means that 6 is equal to a plus b plus c. Using this information, we can now solve and obtain the general term for this original sequence. So let's do that. Let's put that into practice. Right, so given what we have that 2a equals to 4. So let's solve for a. So that means that a equals to 4 divided by 2, which is 2. Right, going back to the slide, we have that 3a plus b is equal to 6. So writing that down. But we know that a equals to 2, so substituting that in, 3 times 2 plus b equals to 6, and therefore b equals to 0. And finally, we have that a plus b plus c equals to the first term, which is 6. So solving for c, a plus b plus c equals 6. We know what a is, we know what b is, so we've got 2 plus 0 plus c equals 6, and therefore we have that c equals to 6 minus 2, which is 4. So we have a equals to 2, b equals to 0, and c equals to 4. So the general term for our sequence Tn, which is an squared plus bn plus c, is equal to 2n squared plus 0 times n, which is 0, plus c, which is 4. Right, so keep in mind, whenever you have a sequence with a second common difference, that second common difference is equal to 2 times a. You then have that t2 minus t1, that first difference, the first one in the line, is equal to 3a plus b, and the first term in the original sequence is equal to a plus b plus c. So working in reverse order, starting at the bottom and then moving to the top, you will then be able to solve for all of the coefficients in the general formula. You will solve for a, take the answer for a, plug it in, solve for b, then take your answer for a and b, plug it in, and solve for c. That is the strategy moving forward. Now let's go on to another question. Right, so let's consider the following sequence. So looking at the sequence, we do not know if there is a first common difference or a second common difference. So let's start investigating what it is that this sequence represents. So let's consider the first difference. 13 minus 3 is 10. 31 minus 13 is 18. 57 minus 31 is 26. 91 minus 57 is 34. So here, in the first difference, it is clear that it is not common. So let's continue with the procedure. Let's compute the difference once again. 18 minus 10 is 8. 26 minus 18 is 8. And 34 minus 26 is 8. So we have a common second difference. And this means that the original sequence is indeed a quadratic sequence. So let's find the general term. We know that Tn equals to an squared plus bn plus c. Remember the formulae that we had used in the previous slide. We know that the second difference is 2a. We know that t2 minus t1, this value of 10, is 3a plus b. And we know that the first term in the original sequence is a plus b plus c. So given all of this information, let's solve for the required coefficients. Right, so solving, we now obtain 2a equals to 8. So therefore a equals to 4. 8 divided by 2 is 4. Looking at the next one, so I've started at the bottom, I'm now moving to the intermediate step. 3a plus b equals to 10. I know that a equals to 4. So therefore b equals to 10 minus 12, which is negative 2. Right, and lastly, now at the top we've got a plus b plus c equals to 3. I know what a is and I know what b is. A is 4. B is negative 2. C is what I'm solving for. and we observe that c equals to positive 1. So therefore, the general term Tn is equal to 4n squared minus 2n plus 1. Right. So keeping that in mind, let's now compute one of the terms in the sequence. So let's say I wanted to find out what is T7. So that is the question. Term 7. So all you'd have to do is then plug in n equals to 7 into your original formula. T7 equals to 4 times 7 squared minus 2 times 7 plus 1. That equals to 4 times 49 minus 14 plus 1. And therefore T7 equals to, so 4 times 49 is 196 minus 14 plus 1 gives us a value of 183. So that means the seventh term in the above sequence is 183. What if we were asked the following question? Right, so that was 1, this is 2, and let's consider this. What term is 241? So essentially what we're being asked here is if Tn equals to 241, what is n? So let's solve for that. So we know what Tn is. We've got the general formula. So we know that 4n squared minus 2n plus 1 equals to 241. Taking all of the terms onto one side, I then have that 4n squared minus 2n plus 1 minus 241 is minus 240, and that's equal to 0. Right. So looking at this, this is certainly a quadratic equation. So there's a quadratic expression in here in terms of the variable n. So we would like to get rid of the coefficient of n squared, but we observe if we divide by 4, we're going to end up with a fraction in the second term. So I'm just going to divide by 2. So divide both sides by 2. I then get 2n squared minus n minus 120 equals to 0. Okay. So now we need to factorize. So you could either use your quadratic formula, or you could factorize and obtain the two factors. The first factor is 2n plus 15. The second is n minus 8. So just looking a bit closely to what this now tells me, this tells me that 2n plus 15 equals to 0, or n minus 8 equals to 0. So in the first equation, I then have that n equals to negative 15 over 2. In the second, I have that n equals to positive 8. Right. But what does n represent? Remember, n represents the term number. Right? So in your sequence, we have the terms running from t1 up to tn, or it continues indefinitely. So therefore, having n equal to a negative number is not valid, right? Because we will not have tn where n is a negative subscript. So that means n equals to 8 is the only correct choice in here, and therefore we conclude that term 8 is equal to 241. So this is where I'm ending in this video lecture. In the next video lecture, I will be discussing geometric sequences and series.